In the space of science and cosmic secrets, the subject of what existed before the Big Bang has sparked discussions and intrigued minds for a long time. This epic curiosity doesn't just test how we might unravel the universe. It challenges the very limits of human knowledge. Imagine standing at the edge of existence, peering into the immense unknown, and pondering what lay there before our universe came into being. The event of the Big Bang marked the beginning of time, space, and everything we know. But what about the moment before this? Could there have been a state of nothingness, a calm before the grand explosion? And if so, was it truly empty, or could there have been something even more profound and unsettling that existed before time itself? As we delve further into this question, science takes us on a journey beyond the universe's origin into realms that challenge our understanding. Physicist Brian Cox, known for his contributions to exploring the wonders of the universe, suggests that something extraordinary might have existed before the cosmic explosion. He invites us to rethink our understanding of reality and existence. In this exploration, we will analyze the science, theories, and astonishing mysteries that could explain what existed before everything. We'll examine ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover might astound you, but they could also offer new insights into our place in the cosmos. Prepare to dive deep into a world beyond imagination, a realm of science where the unknown lingers in the shadows, leaving experts both amazed and, at times, unsettled. Let us explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what might have existed before the Big Bang, we first need to examine what the Big Bang truly was. As scientists describe it, the Big Bang refers to the moment when the universe became incredibly hot and dense, expanding rapidly to set the stage for the formation of all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this hot origin, with galaxies spreading out from a singular point. But why did this happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or tranquil. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and vast, like a giant vacuum. However, this vacuum wasn't entirely empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This expansion, known as inflation, happened so quickly that it effectively set the stage for everything that followed in a fraction of a second. Space expanded at incredible speeds until the inflation slowed down, and the energy transformed into particles of matter and the forces we observe. But what was the nature of this energy? Why did it appear out of nowhere to create the universe? And why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each undergoing its own Big Bang. Imagine a fabric stretching continuously, with tiny bubbles forming here and there, each bubble representing a universe, including our own. This concept, called the inflationary multiverse, suggests that there are potentially infinite Big Bangs and a limitless number of universes. Ours is just one of many. This mind-bending idea challenges our understanding of the very nature of the universe and leaves us wondering, what else is out there? The notion of nothingness before the Big Bang is speculative, not factual, based on our current understanding. Even if you remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an intricate fabric of existence. Even in its most barren state, the universe creates new forms of energy. This fact alone is baffling to scientists, as it suggests that true nothingness might be impossible within our understanding. Space itself has properties, rules, and constants that prevent it from being entirely empty. Imagine creating a region with nothing in it. No particles, no radiation, no energy. Yet quantum fields and fundamental constants would still exist. For instance, there's a phenomenon called zero-point energy, which represents the lowest energy state of quantum fields. In this state, particles can still spontaneously appear and disappear, creating a subtle hum of activity even in what should be empty space. This challenges our concept of a true void and suggests that, yes, even before the Big Bang, there was something scientists are still trying to comprehend. One of the most fascinating theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible it could continue indefinitely. Brian Cox describes an endlessly vast inflationary multiverse where universes are continually created and keep expanding. Imagine each Big Bang as a spark, igniting a new universe, while inflation continues in other regions, creating countless other universes. This process could, in theory, go on forever. This idea of universes giving birth to others leads to a striking concept of a fractal universe, where each new universe might create its own Big Bang. Each universe exists as a separate, independent space, unaffected by the others due to the rapid expansion of space. For researchers, this theory is both thrilling and unsettling, as it suggests an infinite multiverse with no definitive beginning or end. Imagine our universe being just a small speck in a vast, infinite landscape, constantly evolving and endlessly generating new universes. And what if the disturbing truth is this? There is no before or after, but rather an eternal cycle of universes forming and decaying. The way we understand nothingness changes when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space. Rather, it's a complex network of energy fields that fill the cosmos, interacting to create everything we observe. These fields are like invisible seas, with particles acting as waves or disturbances. Even when these fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can spontaneously appear and disappear within these fields, momentarily borrowing energy before vanishing. This phenomenon creates virtual particles, fleeting entities that exist for an instant before dissolving. The existence of virtual particles challenges the notion of an absolute void. Imagine an empty universe where all matter, radiation, and energy are removed. Would there truly be nothing? According to quantum field theory, the answer is no. Even in a vacuum, the fields remain active, occasionally producing transient particles. This constant motion in what should be nothing suggests that the universe doesn't conform to our concept of emptiness. These insights raise an intriguing question. If quantum fields create particles, and particles form matter, could the universe itself have emerged from this so-called nothingness? Dark energy, a mysterious force driving the accelerated expansion of our universe, adds another layer to this enigma. Could dark energy have existed before the Big Bang? Some theories propose that the very presence of dark energy today is a remnant of an energy field predating our universe's creation. The properties of dark energy hint at a vast, hidden force that might have played a role in shaping the cosmos before the Big Bang. Some researchers suggest that in its more potent state, dark energy could have powered the inflationary phase, driving the rapid expansion of space that led to the Big Bang. The presence of dark energy implies that even if the universe were stripped of all matter and radiation, this force would persist, continuing to shape spacetime. This leads to a profound question. If dark energy existed before the Big Bang, could it have set the conditions for the birth of our universe? Could dark energy be the silent architect of inflation, or even the ultimate origin of existence? As we ponder this possibility, we confront the notion that dark energy may not only shape our universe's future, but also hold the key to its mysterious past. Theories like the multiverse, eternal inflation, and quantum field activity challenge everything we know about the origins of existence. Each new discovery pushes the boundaries of human understanding, suggesting that the answers to the universe's most profound mysteries may lie far beyond our current reach. Ultimately, exploring what existed before the Big Bang is not just a quest for scientific knowledge, but also a journey into the very nature of reality itself. It forces us to ask difficult questions. Is there such a thing as nothing? Is our universe unique, or just one of countless others? What are the limits of time and space? Science continues to evolve, offering glimpses into these deep mysteries. Each step forward reveals how much more there is to learn about the universe and our place within it. The quest to understand what came before the Big Bang is a testament to human curiosity and our relentless desire to uncover the unknown. The universe, yet as a key, could open the privileged insights of the multiverse itself. Another speculation offers an option in contrast to the Big Bang as the definitive beginning: cyclic cosmology. This model suggests that the universe goes through tremendous patterns of birth, death, and restoration. In this model, the Big Bang is not a one-time event but part of an undying cycle where universes evolve, break down, and then recover in another cycle. This speculation suggests that our universe may have been renewed from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would imply that there was never a genuine beginning, but rather an everlasting series of universes arising, developing, and restoring themselves repeatedly. Cyclic cosmology raises significant questions about time, as it suggests that time itself may be cyclical rather than linear. If this theory is correct, it could imply that what existed before the Big Bang was simply another form of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers a rich answer to the question of extreme origins, proposing that there is no obvious starting point. The universe has always existed in some form, transcending our concepts of time and existence. Gravitational waves are another intriguing concept that could shed light on what existed before the Big Bang. These waves, discovered in 2015, are ripples in spacetime caused by massive cosmic events. Some experts believe that gravitational waves could carry evidence of events that predate the Big Bang. These waves could, in theory, offer a glimpse of what the universe looked like before it became observable to us, pushing our understanding of the universe's origins even further. The possibility of a pre-Big Bang universe is, undoubtedly, one of the most mind-twisting ideas in modern physics. There are as many ideas as there are stars in the sky. What might have existed before the Big Bang? Could there have been something we simply cannot yet observe or measure? The more scientists look, the more questions they ask. However, one thing is clear: this quest for the unknown will continue to fuel curiosity and exploration for decades to come. As our understanding of the universe expands, the question of what existed before the Big Bang remains one of the most profound mysteries in science. Theories like the inflationary multiverse, dark energy, quantum field fluctuations, and cyclic cosmology provide tantalizing clues, yet no definitive answers have emerged. Each theory raises more questions, challenging the boundaries of our knowledge and imagination. The more we learn, the more we realize that the nature of our universe, its origins, structure, and ultimate fate, may be far more complex and mysterious than we ever imagined. For some, the idea that there might be no true beginning to the universe is a difficult concept to accept. The traditional view of the Big Bang as the distinct starting point of everything is deeply ingrained in our understanding of spacetime and existence. Yet, as scientists push the boundaries of physics, it is becoming increasingly evident that the true story of the universe is far more intricate. Concepts like the multiverse, in which countless universes exist with their own rules and laws of physics, suggest that our universe is just one of many that may have arisen from a complex, interconnected cosmic process. As we delve deeper into quantum mechanics, we are confronted with the possibility that the very fabric of spacetime is not a static backdrop but a dynamic, ever-changing substance. The quantum vacuum, which we once considered empty space, is now understood to be teeming with virtual particles, fluctuations, and fields that may have played a role in the creation of our universe. These particles pop in and out of existence in a way that defies our classical understanding of reality, suggesting that even in the deepest voids of space, there is no true emptiness, only the potential for new states of matter and energy. This leads to another fascinating possibility. The universe we observe today may have been born from a quantum fluctuation. In this view, the entire universe could have emerged from an imperceptibly small point of highly concentrated energy, with the Big Bang serving as the moment this energy was released. This idea fits within the framework of quantum mechanics, where uncertainty and fluctuation are not only common but fundamental to the behavior of particles and fields. Such a scenario raises profound questions about causality and the nature of time itself. If the universe could arise from nothing, then how do we define what came before the Big Bang? The role of dark matter and dark energy in these speculative theories cannot be overstated. These mysterious forces, which make up the majority of the universe's mass and energy content, remain poorly understood. Dark energy, in particular, is a force driving the accelerated expansion of the universe, yet its origins and properties remain elusive. Some scientists speculate that dark energy could have been a crucial ingredient in the rapid expansion of the early universe, influencing the outcome of the Big Bang and potentially playing a role in the creation of the multiverse. Another intriguing possibility is that the universe is in a state of continuous rebirth, one in which time itself is cyclical. In this scenario, each Big Bang might be the result of the collapse of a previous universe, a perpetual cycle of cosmic creation and destruction. The concept of a cyclic universe challenges our traditional view of time as linear, suggesting that the universe may have no true beginning or end. This perspective aligns with ancient philosophical ideas, where the universe is seen as eternal, with no definitive start or finish but an ongoing process of transformation. As we continue to explore the nature of reality, one thing is certain. The questions surrounding the origin of the universe and what existed before the Big Bang will continue to fuel scientific investigation and philosophical inquiry. Each discovery brings us closer to understanding the fundamental workings of the universe, but also opens up new mysteries and challenges. As our tools for observing the universe evolve, from powerful telescopes to advanced particle accelerators, we may one day uncover answers to these age-old questions. For now, we are left with the humbling realization that we are still only scratching the surface of the cosmic mystery. Perhaps, in the end, the true answer to the question of what came before the Big Bang is something beyond our current comprehension. A mystery so vast and profound that it may take humanity centuries, or even millennia, to fully grasp. Yet, the journey to uncover this secret is a testament to the boundless curiosity and ingenuity of the human spirit, ever striving to understand the universe and our place within it. This ongoing quest to understand the universe is not only scientific but deeply philosophical. It challenges the very way we think about existence, time, and causality. What if time, as we perceive it, is merely a construct, a byproduct of our limited perspective within a vast, multidimensional reality? Some theories propose that before the Big Bang, time as we know it did not exist. Instead, there may have been a timeless quantum state or even a different dimension of time altogether. Such ideas extend beyond physics and into the realms of metaphysics, where the lines between science and philosophy blur. Questions arise about the nature of reality itself. Is the universe deterministic, governed by unchanging laws, or is it probabilistic, shaped by randomness and chance? If the latter, what does that imply about our ability to ever fully understand the cosmos? The multiverse hypothesis, for instance, forces us to confront the possibility that our universe is just one of an infinite number. In such a framework, every possible outcome of every event may play out in parallel universes. This raises profound existential questions. Are there versions of us existing in other universes, living entirely different lives? If so, what does that mean for concepts like identity, choice, and free will? Moreover, the exploration of what existed before the Big Bang often leads to the consideration of ultimate causation. What caused the universe to exist at all? Theologians, philosophers, and scientists have wrestled with this question for centuries. While some attribute the origin of the universe to a divine creator or an ultimate cause, others argue for naturalistic explanations, such as the spontaneous emergence of the universe from a quantum vacuum. Interestingly, recent advances in cosmology and quantum mechanics suggest that the universe might be self-contained, with no need for an external cause. Theoretical physicist Stephen Hawking famously proposed that the universe could be finite but unbounded, meaning it has no edges or starting points, it simply exists. This idea is analogous to the surface of a sphere. It is finite in size but has no beginning or end. As humanity delves deeper into these profound questions, the tools we use to probe the cosmos are becoming increasingly sophisticated. The James Webb Space Telescope, for example, is already providing unprecedented views of the early universe, potentially shedding light on the moments following the Big Bang. Similarly, experiments at particle accelerators like CERN's Large Hadron Collider aim to recreate the conditions of the early universe, offering clues about its fundamental building blocks. These scientific endeavors are complemented by advances in theoretical physics. Concepts like string theory, loop quantum gravity, and the holographic principle suggest that our universe may be part of a much larger and more complex reality. For instance, the holographic principle posits that the three-dimensional universe we perceive may actually be a projection of information encoded on a two-dimensional surface, a mind-bending idea that challenges our understanding of space and reality. As we push the boundaries of knowledge, the universe continues to surprise us with its complexity and beauty. Every answer we uncover seems to lead to even deeper questions, reminding us that the pursuit of truth is a never-ending journey. Yet, it is precisely this journey that defines us as a species. The mystery of what came before the Big Bang may never be fully resolved, but the search itself enriches our understanding of the universe and our place within it. Whether we ultimately find answers or not, the act of seeking, of questioning, exploring, and imagining, reflects the limitless potential of human curiosity and creativity. In the end, the story of the universe is also the story of us. Sentient beings capable of looking up at the night sky and wondering about its origins. Perhaps that wonder, that relentless drive to understand, is the greatest mystery of all.